Okay, hello. So today, as I said last time, we're going to have a look at this concept here. So the concept of pressure. We've met it a few times. We haven't fully gone into a lot of detail about it, so I'm going to try and do a bit more on it today. And I've got some lovely questions for you to have a go at shortly. Okay, so pressure essentially is the amount of force pushing on a certain area. So the amount of force pushing on a certain area. Okay, so if I had let's just say my hand, if I press down on my hand, the more I press down on my hand, the higher the force, then the more pressure I'm going to be applying to wherever I'm pushing. So I'm pushing down on the table like that. If I push even harder, which you can't tell I'm doing, but I can tell, the pressure would be greater. Okay, so it's all to do with these two things. Force, which we know is always going to be measured in newtons, and area, which we can measure in various units. Really, we tend to use meters squared, but actually for some things we might use something like centimeters squared, or even if we're looking at a big area like in a country or something, then we might use kilometers squared. Okay, so generally we're going to be using probably those two when we're talking about pressure. Okay, so the first thing we need to talk about is how to work pressure out. So there is a formula, and you've been doing a lot of formulas in maths recently, so hopefully you'll be able to work out how to rearrange this if you needed to. So the formula is, and I showed you this the other day as well, the pressure is equal to the force divided by the area. Okay, so in terms of units, there are various ones that you can use. So you really need to look at what is it that you have put into your formula. If you put your force in newtons and you did your area in meters squared, then you can either put your unit for pressure as newtons per meter squared, that's absolutely fine, or there is a special unit which you can use if you want to, which is called a Pascal, or if you're going to write it down, it's PA. Okay, but you can only use pascals if you are using newtons and meters squared. If you're not using newtons and meters squared, to get it into pascals you'd have to convert so that everything is in newtons and meters squared, which can be quite difficult. So it is absolutely fine to use this as a unit of pressure, as well as this. Okay, so some of the questions that you're going to do call for you to work things out in centimeters squared, in which case you would get the unit newtons per centimeter squared. That is not equivalent to pascals. Okay, so you can't put whatever number you come up with as pascals if you've got this unit. Okay, you have to only do that if you've got this. So if you're interested, that's the unit. I'm not too worried really whether you use this, or that, depending on what you've worked out. But the key is you must look into what you've put in. Okay, and whatever it is, if you're in doubt, just do the force is nearly always newtons slash whatever your area unit is. So it could be centimeters squared, it could be meters squared, it doesn't matter. Okay, so what we need to look at then is how these two things will change this. Okay, because there are some things that you can do, and we're going to use a little bit of simple maths to kind of demonstrate this. So if I go up here, we've got, I'll write my formula again. So we've got pressure equals force divided by area. Okay, so if we imagine that my force was, let's say something really easy, 1 Newton, okay, and my area was 2 meters squared. Okay, it would be very small pressure. Okay, so if I put those numbers in, I'm going to get my pressure is equal to 1 divided by 2 so my pressure becomes half, and I've got newtons per meter squared. Okay, now if I change the area but leave the force the same, so I've got 1 Newton of force, but instead of 2 meters squared, I've got, let's say, 4 meters squared. If I do the same thing again down here, pressure equals force stays the same, area changes to a bigger area, my pressure has turned into a quarter instead of a half. So my pressure has decreased if my area increases. Okay, you can see that really simply with this simple maths. So if then, what does this tell us? It tells us that if the force remains constant, which mine has, it's stayed at 1, then what we're going to get is a larger area is a smaller pressure, just like this. A larger area, there's my larger area here, and my smaller pressure, because if I wanted to put this as decimals, this would be 0.25, this would be 0.5. Okay, so this is a smaller pressure for a larger area, and the converse is true as well. If I've got a smaller area with the same force, then I've got a larger pressure. And that kind of brings us back to what we were talking about the other day, which is the end of the arrow. Remember, at the end of the arrow with the smaller point, the less area as opposed to the larger point had a larger pressure because it was acting, the same force was acting over a very small area. Okay, now we can do a similar thing, but instead of changing the force, we can keep the area the same. Okay, so if I go down here and do the same thing again, so I've got my pressure equals force divided by area. Okay, so let's this time with some simple maths keep the area the same and change the force to see what that does to the pressure. So let's say I have a area which I'm going to keep the same as what should we say, 2. Let's say 2. Okay, 2 centimeters squared. And if I'm going to change my force, so let's say my force is 4 newtons, then if I do my little sum over here, my pressure is equal to force, which is 4, divided by area, which is 2, and I can do that, 4 divided by 2, so my pressure is 2 centimeters, it's over centimeters squared, sorry, so it's going to be 2 newtons per centimeters squared. Okay, so 2 newtons per centimeter squared. If I keep the area the same, so I'm going to keep it as 2, and this time I'm going to change my force to let's say double the force, so let's say this time we're going to change it to 8 newtons. So my sum becomes P, pressure is 8 divided by 2. 8 divided by 2 is 4 newtons per centimeter squared. So if we change the force but leave the area the same, then a larger force like this one is going to equal a larger pressure. And a smaller force, like this one, 4, is going to be a smaller pressure. So if we were thinking about something like a drawing pin area of the point remains the same. So the harder I push the drawing pin, the larger the force, then the more pressure I'm going to put that pin under. Okay, and the converse is also true. If I only use a small force, then I'm going to get a small pressure. Now, lots of questions that you end up doing are really focusing on kind of what's going on with the force, what's going on with the area, and as those two things change, what is going to happen to the pressure. So we're really thinking large area, small pressure, small area, large pressure, large force, large pressure, small force, smaller pressure, and it all kind of links in together. And you'll see when you come on to do some questions after you've watched this that it is actually it can get quite complicated, and you have to really think things through with pressure. Now, just a note on like people standing, because again, lots of questions are to do with standing up. Okay, so here's a question. So let's say somebody is wearing trainers, and we knew their mass. How would we work out the pressure? Okay, so if we knew their mass, which would be in kilograms, the first thing we need to remember from last time is that we need to be able to convert that into the force of weight in newtons. Okay, so we need to do mass times by gravity. Gravity. Oh God, I can't spell. I was going to write gravitational. Oh well, will. Gravitational pull of the Earth. Okay. So we've got, let's say someone of 70 kilograms for argument's sake. We would times that by 10 to get it to weight, because 10 is on the Earth, the gravitational pull. Okay, so we have got then their weight is 70 times by 10, which hopefully we can do. Their weight becomes 700 newtons. Okay, so we've got the first part needed. If we've got 700 newtons, that is their weight. That is going to be the force downwards onto the ground. Now, the other thing we need to work out to think about the pressure that they are putting onto the ground, or what we might need to know, is the area of their shoes. Now, quite likely that's going to be in centimeters squared. Okay, area of their shoes. Now, either the question might give you the area of their shoes, in which case it's nice and straightforward, or it might ask you, how might you work out the area of their shoes? And there is a very kind of crude way of doing this. You just simply take their shoes and draw around them on centimetre squared graph paper, and then you can count up the number of centimetre squares to work out how many fit into their shoes. Now, obviously, if they're standing on 1 foot, then all of that weight is going to press down on that one shoe, so we've got a smaller area, so therefore a larger pressure, or it'll be on 2 shoes, so it's really careful. You need to be really careful and make sure that you're really confident on what's going on in the question. Lots and lots of questions, things about like snowmobiles, skis, snowshoes, and it's all to do with this kind of concept that we talked about up here, about the larger the area, the smaller the pressure. Because if you've got a large pressure on something like sand or mud or snow, then quite often you might well find that you are either sinking in into the snow or into the sand or whatever, or if it's ice, you might well break it and fall through the ice. Okay, so let's see whether you can have a go at doing some force over area questions. So you can use your calculator if you want to, so if you haven't got it, just pause the video now and go and get it. Okay, right, so using the formula, pressure equals force divided by area, could you please have a go at working out the pressure if the force is, I'm just going to put F for shorthand, is 20 newtons and the area is 10 centimeters squared. Okay, you shouldn't need a calculator for that one probably. Do that now, pause the video. Okay, so hopefully you did 20 newtons divided by 10 centimeters squared, and you ended up with 2 newtons per centimeter squared. Okay, I am going to type some more questions out rather than try and make them up on the spot from here, for you to have a go at. I'm actually going to get you to do the workout of the book that I'm going to attach shortly, because you've still got to mark your work from the other day, or you may have already done that. But I will put some questions together for you to have a go at these, so I can think of some more difficult ones and some rearranging ones at some point in the next few sessions. It probably won't be until next week now, so we'll come back to it then. Very good luck completing the book. It summarises really well what I've just talked about. Okay, so if you're not quite sure, you've got two options. You can either re-watch this video or just re-watch a bit of this video, and really important that you read really carefully the task 2 PDF, which is a scan of the book, because it's got loads of information. It goes through very clearly the same thing that I've just gone through. Okay, so best of luck, and we'll come back to that and mark it the following session, which I think is tomorrow, Thursday. Okay, bye bye.